In this short series, I want to cover fundamental programming concepts. Before going into anything, we won't be writing any code. The main focus will be on introducing you to core concepts around programming using relatable examples from day-to-day life. The reason I'm covering these videos without jumping into writing any code is to help people who may be interested or curious about programming but have little to no experience. Once you're familiar with these foundational aspects of coding, we'll then apply our newly acquired knowledge to real examples using a programming language. In this first lesson, I want to touch upon some of these fundamentals so you generally have an idea how they work, and then we'll explore them in more detail in subsequent lessons. While we are creative, machines are very literal, so if we were to write a program to get a computer to perform a series of tasks, then you need to cover every last detail. You decide you want a hot beverage, and you make the decision to go for a coffee on the basis that it's early in the day and you wouldn't mind having a caffeine boost. Here's a simple example of how this might look as a program. There are two possible actions that you can do, either have a coffee or have a tea instead. If the time is between 7 and 11, then make a coffee, otherwise make a tea. In this statement, something will always happen no matter what, because either the time is between 7 and 11 or it's not between 7 and 11. In each possible scenario, there is an action. We check the time, which currently happens to be 9:54 in the morning. So our if statement is true because 9:54 is between 7 and 11. We therefore make a coffee. If the time happens to be later in the day, say 1:43 in the afternoon, our if statement evaluates to false because the current time is not between 7 and 11. So the else statement is then used. In programming, these are called conditional statements, and you'll see them everywhere. Conditional statements allows us to perform different actions for different decisions. This way of thinking is how you would write a program. If something is true, execute that block of code. If it is not true, move on to the next statement. The code will be executed from top to bottom. If-else statements are very common, but you can also add more conditions quite easily by using else-if. If this is true, do this. Else if this is true, do this. If all the above fails, just do this. Hopefully you get the gist. You can just add as many else-ifs as you wish based on how many conditions you require. So in our example, if the time is between 7 and 11, make a coffee, otherwise make a tea. We can easily expand on this logic by including an else-if statement. If the time is between 7 and 11, make a hot coffee. Else if the time is between 11 and 3 in the afternoon, make an iced coffee, otherwise make a tea. Since we have an else statement at the end, something will always happen, but now we have more options. When we evaluated our conditions, we made a comparison against the current time. In programming, these are called comparison operators. Here's an example. The double equals symbols represent the equals comparison operator. This operator checks whether the value on the right, which is 2, equals the value on the left, which is 1. It will return either true or false. I'll just mention now, you've probably noticed I'm using the terms true and false. True and false are a data type called Boolean. Think of Boolean types as either yes or no. We'll cover data types in more detail later in this series. The number 1 is not the same as number 2, so our comparison will be false. Here we have a 1 as the left value and a 1 as the right value. In this case, because both of these values are the same, our operator will return true. Two other comparison operators that are commonly used are the greater than and the lesser than operators. So we're saying, is 1 greater than 2? This will return false, of course. You can also combine equals to either one of these operators, like so. This means that if 5 is greater than or equal to 5, then return true. So although 5 is not greater than 5, it is equal to it, so we get true. And this one, 9, is neither less than 5 nor is it equal to 5, so we get false. These are commonly used when comparing dates and time. Back to our example then, this is how you would write this statement. If the time is greater than or equal to 7, and the time is lesser than or equal to 11, which is anything between those two times, then return true. There's something else we've covered so far, but haven't mentioned, and those are logical operators. Logical operators are very important in any programming language, and they help us take decisions based on certain conditions. You'll use these all the time, and they are and or operators. We've actually used both in our examples. Our original condition to check whether or not we should make a coffee includes both of these operators. When we use and, we're saying that we require both sides, or operands, of the and operator to be true. So if the time is 12, then our left operand is actually true, but our second operand is false because 12 is not lesser than or equal to 11. However, because we're using and between the two checks, then both operands are required to be true. The OR logical operator is different in that only one of the operands needs to be true. So for instance, if we change the AND to an OR operator, this condition will now evaluate to true, because one of them is true. This greater than or equal to 7 comparison is an example of where we used OR logic. We can expand it like this to show the OR operator to make it slightly easier to understand. The time needs to be greater than or equal to 7 to be true. Another example we can all relate to is making food. We're specifying a list of instructions just like a recipe list. Think of cooking as two parts. You have the ingredients and the cooking method. The cooking method describes the process, and the ingredients tells us what we can use in that process or what is available to us. The ingredients are the values and the cooking method is the actual program. One of the core concepts of programming are variables. Think of a variable as the frying pan that holds the ingredient. We can name this variable pan1 or declare this variable as pan1, which is currently an empty variable or an empty frying pan. If we inspect pan1 and try to retrieve the value of this variable or take a look into the pan, we get nothing because the pan is empty. No value has been assigned to the pan yet. We also need a dish so we can store our chopped onion, and we've named this variable or declared this variable as onion dish. What is the value of onion dish currently? Well, it's empty because we haven't added anything to it yet. We can then assign values or ingredients to these variables, so for onion dish we can add 1 large chopped onion. Now the value of this onion dish variable equals 1 large chopped onion. Now we can add the value of onion dish to pan 1, or in other words we can tip the onions into the frying pan. Now pan 1 contains onions. If you were to inspect the contents of pan 1, you'll see the value is 1 large chopped onion. As the name variable suggests, the value can change. This leads on to assignment. In programming, when you assign a value to a variable, you're not moving the value from A to B. You're creating a new copy of this value and then assigning it to that variable. What we're saying is we want the value of pan 1 to equal the value of pan 1 plus the value of onion dish. Let's break down what's happening here. The equal symbol is the basic assignment operator, and the plus symbol is an arithmetic operator. An assignment operator assigns a value to its left operand based on the value of its right operand. In the right operand, the value of onion dish is added to the value of pan 1, effectively creating a copy of 1 large chopped onion. This new copy is then assigned to the left operand, updating the value of pan 1 from empty to 1 large chopped onion. We'll take a more detailed look at assignment operators and variables throughout the rest of this series, so you generally have a better idea of how they work. This was just a short introduction to some core concepts of programming, and I hope most of it made sense. If not, just rewatch it a few times, and then move on to the next video where I will go into variables in a bit more detail. Please leave any questions, comments or feedback you might have in the comments section below, and I'll see you in the next video. Thanks.